Okay, concept 15 is graphing polynomials. In number 33, you're given the number line representation for the graph of the polynomial, and you're asked to write an equation for the polynomial. It's helpful to first visualize what the graph looks like for some people before they write the equation, rather than just directly writing the equation from the number line. So the shaded portion shows that the graph is positive when we are at less than -5. So we can show the graph being positive here. Then the unshaded portion means that between -5 and 0, our graph turns negative. So we would have something like this. Now at 0, between 0 and 6, the graph stays negative, which is shown by the unshaded portion here. So we can assume there's a bounce here. And after 6, numbers greater than 6, the graph still stays negative. So there's another bounce there. So we can kind of see what the sketch of the graph would look like. So now let's write the equation that corresponds with this. So our roots are at +6, which would be a factor of x minus 6, at 0, which would be a factor of x, and at -5, which would become a factor of +5. Now let's look at the end behavior of the graph. The end behavior is negative. That means that our coefficient in front of the equation is a negative number. And lastly, let's see if we can determine what the exponents of these factors are. At -5, the graph goes through the root. So here the exponent is a 1. At 0, we have a bounce. A bounce determines that our exponent is squared, a 2. And at 6, we also have a bounce. So again, at 6, we have an exponent of 2. So looking back at our equation, a few things that you should do to double check are first to check the end behavior, which is negative, which determines this. The factors are determined by the roots. So -5 gives us the x plus 5. The 0 gives us the x. The 6 gives us the x minus 6. And lastly, the exponents, our bounce occurred at 6 and at 0. So our exponent of 2 is at x minus 6 squared and x squared. Now on number 34, let's again sketch what the graph would look like based on the number line. So we have a graph that is positive when we're less than 2, a graph that's staying positive between 2 and 5, and it is turning negative after 5. And then when we get to +8, the graph becomes negative once again. So looking at our equation, so let's start with looking at the end behavior. The end behavior is positive. So that means rather than having a negative as my leading coefficient here, I'm going to leave it as a positive. The roots, so we have a root at 2, which would make a factor of x minus 2. And we can see there's a bounce there, so I'm going to square it. At +5, which means we have a factor of 5, that's going through that root, so the exponent is 1. And at +8, which would be a factor of x minus 8, and that is also going through the root, so the exponent is 1. So we have a final equation there. On 35, we have an equation, and we're first asked to state the degree. So easy way to find the degree is add up the total of the exponents for the x. So x cubed, x to the first. So 3 plus 1, the degree is 4. The roots, the zero product property shows us that either x is equal to 0 or x minus 4 equals 0, which means x is equal to 4. And let's look at our exponents. This has an exponent of 1, which means that at this root, we should just go through the root. And an exponent of 3 tells us that we should go through the root, what we call slowly. So let's plot our roots. We have a root at 0 and a root at 4. And in order to start the graph, let's look at the end behavior. The end behavior, because of this -1 in front, is going to be negative. And at +4, we noted here that we need to go through the root slowly. So rather than going through like that, we're going to have a little bit of a bend in the graph. So let's bend our graph a bit to go through the root slowly. And at 0, we can simply go through. So after going through 4 slowly, we can just go through at 0. And on number 36, our degree, so we have x squared, an x, and x. So 2, 3, the degree is again 4. Our roots, x plus 3 equals 0, so x equals -3. X minus 2 equals 0, so 2. X minus 5 equals 0, so a root at 5. And also, it's good to write these as x-intercepts, which I forgot to do here, so I'm going to write them as points. So -3, 0, 2, 0, and 5, 0. And let's go ahead and plot those. So -3, +2, and +5. Our end behavior, we have a positive coefficient, so the end behavior is positive. And we need to note here that there's going to be a bounce at the root of -3. Both of these will just go through the roots. So this one is going to go through, this one is going to go through, and this one at -3, there will be a bounce.